we have this isomorphism business, and how this would look with our G1 being 1, 2, 3, and our G2 being A, B, C. So here, V of G1, we said was the set 1, 2, 3, and E of G1 was the set 1, 2, 3. V of G2 is equal to A, B, C, and E of G2 is equal to A, B, B, C. How can I exhibit an isomorphism between these? I need a function. I need an alpha that starts with things in V of G of 1 and then maps it to things in V of G2. So what would you propose for this alpha function? My domain elements be 1, 2, and 3. What should I map 1 to? I can map 1 to A, 2 to B, 3 to C. You agree? Then, all right, now we have to check, okay, is this 1-to-1 and onto? That's the first thing. Is this function 1-to-1 and onto? Yes. Next question is to look at the edges we have originally and compare them to the edges that we have in the image. So I have to look at the edge 1, 2, which gets sent to A, because I replace 1 with A and 2 with B. That is an edge. That's good. I look at 2, 3, which gets replaced with BC, and that's an edge in the second graph, so that's good. Now I have to look at phi of 1, phi of 2, which is AB. This is an edge in the second graph. And the 1 and the 2 are also an edge in the second graph, or first graph, so that's good. And then I have to look at phi of 2 and phi of 3, which is an edge in the second graph. And the original 2 and 3 are edges in the first graph. So this would be my if condition, this would be my only if condition. We check, and it is an isomorphism. So if you're handed a map and someone says, is this map an isomorphism? Theoretically, it's easy to check. It does take, it takes some time. But in a computer, you could write a computer program that could check both of these things pretty straightforwardly.